And we will go to Paul. So Paul is very important for our community because it's the first on the line to produce a initial working plugin that you can even now, if I'm not mistaken, Paul, use if you have the ability to, compile everything. Correct?
Yeah, that's correct. If you're willing to build ATAK yourself, you can use my plugin. Definitely excited for the plugin signing system to open up.
So Paul, you are presenter now. You want to share something with us?
Sure, here you go. And let me just get this into slideshow mode. So yeah, thank you. Hey everyone, my name is Paul Mandal. I'm a software engineer who enjoys hiking in his spare time, and I spend a good amount of time in the backcountry. So ATAK is really appealing to me because of the really wide variety of map sources you can use with it, how easy it is to create offline maps of an area, and the 3D mapping and route planning tools I think are really excellent for hikers. I'm also a big believer in the open source software movement, so having this kind of powerful mapping platform that's easy to integrate with is like a really great opportunity from my perspective. I think ATAK can provide a lot of value to the outdoors community. I could see people creating data packages containing routes and geolocated pictures of nice camping locations and views or water sources and sharing them with the community. Could also be great for groups that are hiking and they're kind of spread out along a trail, but they want to be able to coordinate or otherwise have some idea where their friends are. So when I first downloaded this thing, I thought it might be possible to get a relatively cheap off-grid solution going for a civilian user, but I couldn't find any solutions that fit my needs. I don't like to let my dreams stay dreams, so I started working on a plugin for off-grid communication. Initially, I was using Gotenna mesh devices because I had a couple of those lying around, but then at the recommendation of one of the users on the ATAK Discord, I switched to Meshtastic and LoRa devices. So in this presentation, first we'll cover ATAK plugin development and just like the main touch points for a plugin. Bear in mind, I don't work at the TAK Product Center. This is coming from the perspective of an outsider. So if you don't find something that you're looking for in here, definitely check out Chris Lawrence's talk. He goes into a lot more detail and talks about a lot more broad API than I do. So yeah, ideally you'll come away from this presentation with enough knowledge to get started implementing your own plugin. As a supplement to this, I've created an example plugin. This is based off the plugin template that's distributed with ATAK with a few little extras to give examples of some common things a plugin might be doing, like listening to messages from ATAK and sending messages to ATAK, having an icon in the corner of the screen for your plugin, some kind of basic UI with a spinner, and different plugin icon types, like the icon that appears in the menu versus the package management. So yeah, let's just jump right in. First up, we'll talk about plugin.xml, which is, if you're listening to Chris's talk, it's a file that ATAK uses to tell where critical classes in the plugin's package are. So the lifecycle class is going to be required, and that's ATAK's going to need that to like instantiate your plugin. The tool descriptor is optional if you have like a UI tool. Some plugins are not going to have anything like that. Next up is just the Android manifest. If you're familiar with Android development, this is a standard file in an Android application. It tells the system some details about the application, things like its icon, what its label is. And yeah, you could see in this screenshot, I've got on the bottom, I have the actual Android manifest, and on the top, I've got a screenshot from ATAK's package management screen, and you can see where like the icon and the label map into that screen. Next up is the lifecycle class. So this is the entry point into a plugin. When ATAK loads a plugin, it's going to look at plugin.xml to find the class that implements this lifecycle, and then it'll look for a constructor that takes a single context. If it finds that, it will instantiate and pass in the plugin context. Otherwise, it will call the no argument constructor and work that way. After your plugin's lifecycle class has been instantiated, the ATAK will call the onCreate method here, and that's where you want to instantiate the rest of your plugins classes. So for in our example, we just have a plugin map component. And we'll cover that in more detail later. That's like a built-in or a standard component for an ATAK plugin. This is not shown in this slide because I had to get all this stuff to actually fit on the screen, but in the example that I linked earlier, there are inbound message handlers and outbound message handler classes that are instantiated here. Other than that, the lifecycle class doesn't do a lot. It should respond to lifecycle events in an appropriate way, and it should pass those events on to other interested classes. So in this example, we've got our plugin map component, and you can see here when onDestroy is called, we're going to need to pass that down to all of those components, and in this case, the plugin map component will find out about that. Same thing for the message handlers. I had to clip that out just to make it fit on the screen, though. This is the tool descriptor class. This provides some useful details about the plugin to ATAK. Here we got a side-by-side image of the class implementation, and on the right side we have a screenshot from the 3 dots menu in ATAK. You can see where the icon and the short description end up showing up in the UI. There's also this groups section, which I don't know a ton about, but I think that has to do with placing things in the radial menu versus other like menu groupings. I didn't need to use that in my plugin though, so can't really comment there. This is the map component class. This is the UI entry point for an ATAK plugin. This is going to instantiate a drop-down receiver, which will act as the UI drawer that pops out when you pull your plugin to the foreground. It also registers the drop-down receiver to handle the show plugin intent, which ATAK uses to show the plugin. And in our example, we also create a marker icon widget. This is going to create like a little icon in the lower right corner of the screen. Our example one's clickable. It'll just open the plugin drawer, but otherwise it doesn't do anything. It just switches its icon. I think the image changes every 2 seconds, and that's just to illustrate like if you wanted to communicate some state to your users. That's like a nice way to do that. Next up, this is the drop-down receiver. This class handles inflating and displaying the UI for our plugin. I would recommend keeping this class really small and just putting all the view and view model code into separate view model classes. In our example, we just have like a simple hello world text and a plugin spinner. You might, if you missed Chris's talk, you might be wondering what is a plugin spinner and why not just use a stock Android spinner. A plugin spinner. So in the ATAK plugin, or in an ATAK plugin, there are 2 context objects that you have access to. You have ATAK context, which is the context of the ATAK application, and that'll be used for UI interactions like dialogues and toasts. And you have a plugin context, which is used for getting resources that are specific to your plugin, like strings, colors, drawables. The stock Android spinner uses it will expect to do both of those things with the single context that it's passed. So it's going to try, like when you tap on the spinner, it's going to try to open that dialog using the same context that it was using to fetch layout resources that you told it to use for the spinner items. And that'll cause your application to crash. So the TAK team has handily included this plugin spinner class, which is just an extension of spinner, and it's built to handle both of those contexts elegantly. This is our marker icon widget class. Rather, this is the plugin component that instantiates our plugin marker icon widget class. And you could see here a little arrow showing what that looks like in ATAK. In our case, I just made a green blob, but you could put any icon in there. You could also put that in, not just in the lower right corner, but I believe in any corner, and probably there's some other spots for that. So yeah, these icons can be clickable. It's a good way to have your plugin open up if you have one anyway. I would also recommend it, or I would primarily recommend this to communicate important state. So in my plugin, I have like external device that the phone is connected to, and if you lose connectivity to that device, it's important that the user knows that. So having something like that turn from green to red is a nice way to show that. So one useful thing many plugins will want to do is work with COD events that are being transmitted from ATAK, and these can describe anything from like PLIs to routes or shapes that should be drawn on the map. So how can you handle an outgoing COD? In our example plugin, it just toasts the type of every outgoing COT that happens. And the way that you become aware, or you can make your code aware of that stuff, is you have to implement a presend processor interface on one of your classes. And then if you call COT map component.set presend processor to that class, it will, every time ATAK is going to send out a COT, your class is going to have a chance to pre-process it. So you could do that to modify the COT. You could emit them through another channel. You can log them. In our case, we just toast the type to the screen. For myself, because I didn't have access to a bunch of COT messages when I was developing, I found it useful to log all the COTs coming out of ATAK and just draw everything that I was interested in on the map and send it. And then I could build up a corpus of messages that way. So yeah, obvious counterpart to handling outgoing messages is creating incoming messages. And thankfully, this is really easy. In our plugin, we create this, you can see it's a fake marker with our version of our plugin in it. Pretty simple to do that. You actually, you can create a COT event manually using the COT event class. If you have XML for a COT event, you can use COT event.parse string. And then when you actually dispatch that, you'll use a COT dispatcher's dispatch method. How do you get a reference to a COT dispatcher? COT map component has two static methods, get internal dispatcher and get external dispatcher. Internal one is used for, I believe, definitely check this, for sending COTs into your local ATAK, and external is for broadcasting those externally through whichever available channel you have. So that's all I have for my example plugin. I'm going to go through some specifics for my ATAK forwarder plugin. Before I go into detail on that, I would just like to stress that this is a plugin made as a hobby. It's not been tested in any way that would qualify it as professional grade. It should not be used where failure would result in the loss of life or limb. Always have a backup and a backup plan. If you're an experienced hiker, you definitely know that you should be doing that. But yeah, having said all that, the ATAK forwarder is a plugin for off-grid communication through ATAK using Meshtastic devices. Meshtastic itself is an open source mesh networking protocol that uses LoRa hardware, which are relatively cheap. I think they're about $30 or $40 a node. The plugin is not currently signed by the TAK Product Center, though I'm going to try to get that signed as soon as that becomes possible. To use the plugin, you're going to have to build your own copy of ATAK and the plugin. And so the main features of the plugin are in-app status and useful stats. Got all this kind of debuggy stuff up here, which is useful for where we are in this stage of development. We have in-application channel management. These data rates are built into Meshtastic. I would definitely recommend sticking with the top two. And we can, once you've set up a channel, you can configure another device using a QR code and just scanning that. We also have full chat integration with the ATAK's built-in GeoChat.
This is new because we discussed that in the chat. So you have now full integration with the real chat?
Yeah, I mean, as full as I'm aware it can be. When you send a chat, it's going to show up in the ATAK chat and you'll get the regular notifications.
Now, can you comment on the fact that certain vendors are creating their own separate chat? Is that, in your opinion, a limitation of their understanding or the documentation? I'm referring to the fact that the original version of the Gotenna plugin and also the current prototype of the Radacat are both using a separate chat, kind of a proprietary chat. Is that so difficult to implement in your opinion?
I wouldn't say it's difficult to implement. I had to dig around a little in the ATAK source to figure out how to do it. And I got some recommendations from people in the community also that helped me out a lot there. But yeah, I would definitely recommend against that approach, just because you're going to have chat messages coming in from different channels essentially, and it could, I don't know, I think it could be a little disorganized to have them coming in multiple places.
Absolutely, and I strongly believe that if you could, write an article in this regard, a lot of, creators of devices would be very interested, especially if you think that currently GoTen is used by the special forces in production, and they have a separate channel, would be very useful for everyone.
Okay, yeah. I mean, I'd be happy to do a write-up like that.
Thank you. Go on.
Yeah, no problem. So yeah, in addition to chat, we also support a transmission of a wide variety of shapes, including routes, basic markers, observation points, custom markers, custom shapes, and medevac. So basically, at some point I just tried to make every shape and thing that I could on the map in ATAK and transmit it, and then just build out support for that. If there is an unsupported message type, I would be really happy to hear about it on the issue tracker in my repo. I want to have the message support to be as comprehensive as possible. I should also add here that I'm thinking about, actually disregard that, I'll talk about that later. So yeah, apart from that, we also support in-app device configuration to pair with your primary device, and we also support non-ATAK devices. So there are Meshtastic devices that have a GPS, and they can be configured to send their location to the network at a regular interval. That can be really nice if you don't need an ATAK end user device. So in my example, I have a dog that I go hiking with. I'm pretty sure she doesn't know how to use GeoChat, so I'd like to just be able to give her like a simple device that I can put on her collar or something and be able to know where she is. So yeah, we support that here. I haven't been able to test this myself because, as you can see in this slide, my devices have never been able to get a lock, but other people in the community who have tried the plugin out have had some success with this. So if you're interested in that, please try it out. Give me some feedback. I'd be happy to make improvements there if you find anything. So I started developing this plugin, and oh yeah, sorry, this is a real-world example. Maya is my little puppy, and you can see getting some decent range in a wooded area here with it. So I started developing this plugin in early August, and it went through several iterations. The first release was a really simple standalone application. I didn't really know much about integrating with ATAK at the time, but I had used Wireshark to like get a little bit of an idea of what was going on the network. So I made this application that you could set up, what are they, network inputs and outputs for, and it would listen to that network traffic coming out of ATAK. It would generate network traffic to send back to ATAK, and the app had a basic GoTen integration and was capable of transmitting PLIs. It used XML for payloads, so a PLI took quite a while to transmit. I'd say about 1 minute, so kind of unacceptably slow, but not terrible for a first iteration. Next iteration was like a proper plugin. I managed to find the plugin template and made good improvements there. Still no UI, but it did have some improvements also to the GoTen integration, and it had peer discovery. After that, I started to reduce the message payload size by using EXI, which is efficient XML interchange to encode messages before they're transmitted. That brought PLI down to about 20 to 30 seconds to transmit, which is like getting okay. For the 0.1.0 release, I added in-app group management. I started supporting chat, and I started using protobufs and message rate limiting to kind of reduce the amount of network traffic. At that point, I jumped a bunch of versions because I made like a pretty wide variety of improvements without doing a release for a little while. I switched to Meshtastic devices, expanded the supported message types to everything I could find in ATAK. I implemented a set of custom protobufs and shaved message payloads down even further. And I also added support for Meshtastic devices that have a GPS but no ATAK EUD. Future improvements I'm looking to make are like...
can you comment on your Protobuf experience? Are you using Protobuf to send the message over Meshstatics and to compress that? Is that the intention? And have you created your own version, or are you using what ATAK is using?
So initially I used the ATAK Protobufs because they were very flexible, but then I also found out that they weren't super efficient. So I started to implement my own. I have a slide further down where I'll go into a little bit more detail on that, but basically like in a GeoChat message, for example, there are a few repeated values. So every time I found a place where there were repeated values, I wrote up some code that will replace that with a symbol that just lets the code on the receiving side know that it needs to fill that back in with the value from another part of the message. And other than that, I tried to uh, re like I reduced message size by, let's see, I took the offset from the start of the year rather than from January 1st, 1970. So that shaved a few bits off of timestamps, and I put timestamps relative to each other and a few things like that. So yeah, in the
Okay,
near future,
and
yeah.
we have another question in regard to Gotenna. Are you using Gotenna Mesh for your testing, and have you dropped Gotenna development so to focus only on open source, or are you continuing to support Gotenna?
So let's see, I was using Gotenna Mesh for my initial development. I've essentially dropped support for Gotenna right now. It would be pretty easy to add it back in. I've kept all the same kind of structures in place that you would need. But the reason I ended up dropping it was I reached out to Gotenna and asked them like what the rules are around redistributing a plugin built on their technology, and they basically told me because it replicates things that they do or products that they may make in the future, they weren't happy with it. So, no problem. That makes sense. But that kind of killed it for me. So I switched over to Meshtastic.
Okay, thank you, go on.
No problem. So yeah, in the near future, I'd like to take what I learned at this conference and improve my ATAK integration. Definitely lots of room for improvement there. I'd like to get some kind of transmission verification in place so network traffic can be reduced further. Maybe something like sending out hashes of UIDs and getting receipt back from, or getting acknowledgement back from other devices that they previously received those stationary objects or something like that. I would also like to I'd like to be sure that when you send out a message that it actually gets there. Right now, there's like I said, there's no message verification, which is not really great necessarily, but yeah, so some improvements that I'd like to make, and I'd like to further reduce message sizes. Yeah, so let's talk a little bit about how the plugin works and its major components, how its major components fit together. To do that, first we'll trace a message coming out of ATAK and being transmitted to other Meshtastic nodes. So when a message is going to be emitted from ATAK, it first goes out through our outbound message handler, which implements the presend processor interface that I mentioned earlier. The outbound message handler first checks against our COT message cache to see if a message has been repeated or see if it's a repeat of a recent message. If it is, it's dropped. Otherwise, the message gets cached for later. And then we attempt to encode the message using our COT event protobuf converter. If this fails, we fall back to the fallback COT event protobuf converter, which is less efficient but a lot more flexible. After that, the message is queued in our command queue. The COM hardware portion, everything on the right here, is going to be running on its own thread. So at some point, it's going to pull that command queue and pick up the message, and it will start handling the hardware-related portion of the transmission. Since most COM hardware has message length limits, we have a class called, this is lengthy, message length limited COM hardware that handles splitting and reassembling messages based on the maximum length that you specify. It uses the first byte of the message to store the message index and the total number of messages in 4 bits each. And once the message is broken into segments, each segment is transmitted by the Meshtastic COM hardware. This class just handles the Meshtastic specific parts of sending a message over the communication link, and that's mostly talking to the Meshtastic service. On the other side of that, when the message is coming in, the Meshtastic COM hardware will receive each message segment and send them over to the message length limited COM hardware for reassembly. Once all the segments for a message have been received, we send that completed message to COM hardware that's going to notify all the interested listeners that have registered with it. Inbound message handler is one of those listeners, and it'll take the raw bytes of the message and try to convert it into a COT using either the COT event Protobuf converter or the fallback COT event Protobuf converter if the previous one failed. And finally, once we have a COT event, we transmit it to ATAK using the COT dispatcher class that we talked about earlier. One other thing that we're interested in here that's not just like messaging from ATAK is, like I mentioned before, non-ATAK or devices that don't have an ATAK EUD attached to them. So we get those as a node update from the Meshtastic API. Our Meshtastic COM hardware listens to that, transmits it to our user tracker class, which tracks which Meshtastic nodes are associated with ATAK users. And if it's not associated with an ATAK user, it's going to go to the non-ATAK COT generator class, which is just going to generate a spoof COT event essentially that contains like a templated PLI. We're going to populate that with our node updates, latitude, longitude, and altitude, and then those get retransmitted to ATAK using the same API for incoming messages that we talked about before. All right. So yeah, as you asked me about before, because all of these off-grid radios don't have very much bandwidth, I spent a healthy amount of time for this plugin's effort, like reducing the payload sizes of the that the plugin's transmitting. So initially I was using XML, which is really inefficient. I switched to EXI, which reduced the message sizes like 20 to 30%, which is pretty nice. But then I was able to reduce this further by switching to protobufs, and further still by replacing any repeated strings with markers, reducing precision on things like altitude to whole meters. And then I also packed a bunch of enum fields and other small fields into fixed length integers, and basically that I'm basically using as large bit arrays. So here's some of the code I used to do that. I have two of these fixed 64 integers that are essentially like large bit arrays for me. You can see I'm using like these timestamps and the height above ellipsoid that have packed down to slightly smaller sizes and reduced a little precision there. I'm probably going to break this out into its own library that simply handles COT payload minimization, because I feel like that's probably something that's useful to the community at large and that I can get some good contributions to. I'll post updates about that on the Discord for others in the community. And this one, same thing, is just more bit masking, bit operation stuff for packing in stuff into the payload. And that's all I got. So finally, I'd just like to say thank you to everyone at the TAK Product Center. Really great suite of applications, lots of potential with this public release. I'd like to thank DBSPL from the Discord for encouraging me to port to Meshtastic devices. I'd like to thank Johan for releasing a custom build of ATAK on this plugin so I could get some feedback from the community. And I'd like to thank everyone who runs the ATAK Discord for making a solid community.
Thank you, Paul. I got first off a statement from Ralph that as soon as you are willing to do that, we are going to have your plugin signed so that everyone in ATAK can use it. So it's up to you when you want to start the process, because it's such a great plugin. A lot of compliments on the Discord also. Another question is coming from Shipdog01. Will messages stay in a queue if no Meshtastic device is connected?
Yes, yeah, if no Meshtastic device is connected, you should see the message queue length marker in the status screen just continually going up. It's not going to go up for repeated PLIs. Like if a PLI is already in the outgoing message queue, it'll get replaced with a new one if a new one comes in. So one way you could test it is just sending chat messages. If you like send a few chat messages, you should see that marker going up.
Okay, another question that is really interesting me is in regard to interoperability between off-grid systems, right? So is any chance that you see to, for example, connect one device with a USB cable and another device with, for example, Bluetooth, so that you have a kind of device that will bridge two different systems like Gotenna and Meshtastic?
Yeah, I don't see any reason that wouldn't be possible. Yeah, you'd have to modify the plugin to be able to handle multiple devices and handle cross communication between them. But yeah, I think that should work.
Okay, awesome. I don't see any additional questions coming from the community, but Paul, thank you again. And I think your plugin is going to be a representative of what this community can do. And I see also a team there, and I would like to point again the fact that Paul has currently realized a plugin that functionally is better integrated than the plugin that the US forces are currently using. That is kind of amazing. And I think that is a very good example of what such a community can do. And with that in
Hold
mind,
on. Hey, before you move on, I want to just say a little. So
yep, go on.
I think we should put together a web page with the plugin when it's ready. Put it in the Play Store with what Meshtastic to buy and how to set it up, so that people could actually, you know, as consumers, do this easily. I'm dying to try this personally. Over.
Okay, that's a great idea. Thank you, Ralph, for that.